I'd like to welcome everybody to our final session of the day. I'm sure we've all had a long day and hopefully very interesting one as well. So this is our session 4A, Extraordinary Fibers, Extraordinary Stories from the Andes and Beyond. This panel is going to explore the subject of very special fibers from the Andes, coming from animals and plants, and the cultural context for their use and identification. We have 5 speakers today, and we will be speaking about a range of materials from the Andes. Originally, we had a 6th speaker who unfortunately could not join us, Judith Cameron from Australia, who is going to talk about asbestos, which is a particularly interesting, unusual fiber. So we will stick ourselves into the Andean region today in South America and not go too much beyond it. Our speakers today are, I'm going to just give a brief intro because you have the booklet which gives everybody's bios and their abstracts. Penny Dransart, who's done research and fieldwork in the Andean region for many years, has numerous published books and articles on textiles and camelids from perspectives of cultural anthropology, archaeology, and art history. Ann Peters is an archaeologist and researcher from the associated with the Penn Museum in Philadelphia. And in recent years, she's been working with a very important corpus of Paracas necropolis textiles and their associated context. Her co-author, who is not joining us in the lecture today, but is hopefully here or reading, is Adriana Soldi from Ica, Peru, who studied anthropology and textile conservation. Myself and my colleague Caroline Solazzo will do our joint presentation. Caroline is the scientist in the Conservation Research Lab at the Smithsonian, who's a specialist in the field of proteomics. And I'm an independent lecturer and independent scholar and lecturer at UCLA. Andrew Hamilton is the associate curator of the Arts of the Americas at the Art Institute of Chicago. And his book, Scale and the Inca, examines in quite detail the special forms of Inca art and culture. So with that, we would like to start our session with Penny.
What I want to do now is to explore the hidden and extraordinary histories of vicuñas, alpacas, guanacos, and llamas, and collectively they're known as the South American camelids. Their histories are inextricably intertwined with those of people because their fiber made garments of particular distinction. So the focus of this talk will be on the second half of the first millennium of the Common Era, when 2 states, Tiwanaku and Wari, rose to prominence in the Andes. What you see on the screen here is a Wari llama on the left and a Tiwanaku camelid on the right. And the red slip of the Tiwanaku camelid is meant to indicate the vicuña color of the fleece. The story, of course, begins a lot earlier than these 2 cultural phenomena. Camelid fiber is notable not only for its warmth and its elasticity, but also for its fineness, its light-reflecting colour qualities, and its colour values. Archaeological evidence indicates that some 4,000 years ago, people in the Atacama Desert had already begun to herd llamas to complement the hunting of wild vicuña and guanaco. Because of the prevailing arid conditions, evidence survives to show that llamas in people's herds had fleece colours similar to those of the wild camelids. To extend the range of colours, spinners selected fibres carefully for dyeing. They combined dyed and undyed fleece colours using the light and mid-brown tawny colours from the sides and the back of the animal, either as they were undyed, or they dyed them red or blue, which seem to be the earliest colours. And this slide here, you see an alpaca that has vicuña coloration, but you see some white appearing here and here. The colour is particularly useful for dyeing red, and which in the earliest days was obtained from the roots of Rilbonium plants. By about 500 AD, the use of cochineal was becoming widespread. Some of the textiles I will show combine yarns spun from undyed fleece with yarns spun from dyed fleece. Wari dyers relied in particular on cochineal and indigo, while Tiwanaku dyers also had expertise in producing lovely yellow colours to extend the range of the undyed fleece colours in their textiles. According to research published in 2006 by Jane Wheeler, Lunes Cheeky, and Michael Bruford, 90% of Peruvian-produced alpaca fibre now measures more than 25 microns in diameter, compared with 17 to 22 microns in pre-Hispanic animals. In the past, spinners and weavers had access to different qualities of fleece, which makes it difficult to identify whether fine yarns in pre-Hispanic textiles were spun from the fleece of vicuña, alpaca, or fine-fleeced llamas. Mummified camelids from the site of El Llanero in southern Peru display more uniformity in fibre diameter and coloration than is present in contemporary llamas and alpacas. Tiwanaku is south of Lake Titicaca in Bolivia, and it exerted political, economic, and religious control in the south central Andes between about 400 and 1000 AD. Similarly, Wari, north of Ayacucho in Peru, came to power in the central Andes about 550 AD to 900 AD. These two political entities originated in the Andean highlands, and they expanded to control inter-Andean valleys and coastal zones. The division between these two regions extends westward from the Nudo de Vilcanota in Peru between the Sihuas and Tambo rivers. And it's precisely in this contact zone that developments took place to increase the availability of white fleece. And this is a point I'll be making later. In making fabrics, Tiwanaku spinners and weavers relied on Camelid fiber yarns. An example is this looped hat with an all Camelid construction. The fibers used for the yarns were selected for their natural colors, white, brown, and gray. Wari spinners used cotton yarns for the warp and Camelid fibers in the weft to weave tapestries for headgear, tunics, mantles, and bags. Of course, they used other techniques too. This hat uses yarns that are both dyed and undyed, with white and brown for the outlining. So Tiwanaku and Wari, as two different but related textile traditions, exploited the colours and other qualities of fibres differently in their fabrics and textiles. But then if we look to what happened before they came to prominence, we can see some interesting developments. The Sihuas Valley is one of the areas where, prior to Tiwanaku and Wari expansion, herders were beginning to produce what seems like greater quantities of white camelid fleece for the use in elite garments. This example of a rectangular textile belongs to what Jörg Haberle called the Sihuas Phase 1, which dates from the end of the first millennium BC. It's woven with a discontinuous warp and weft, and that's a technique that heightens the whiteness of the white against the darker surrounding colours, as well as making economical use of the white, which seems not yet to have been widely available in large quantities. And I also draw your attention to this central face here, which is a characteristic of these textiles. And here's a close-up of the discontinuous warp and weft. So the white only travels in the area in which it's apparent in the textile. This Nazca effigy bottle shows a woman leading an all-white llama. And because she's got a bundle of firewood on her back, it seems as though the llama is being taken for sacrifice. So this is an interesting example of an actual depiction of an all-white camelid. So I'd also draw your attention to the Nazca style here, where you've got the black outlining, especially in the hand. Now, again, I'll come back to that later. Both Tiwanaku and Wari textile traditions also share roots in Pukara textiles, which depict a rayed head. The site of Pukara is north of Lake Titicaca, and I draw your attention here to the use of the split eye, which again you will see in further textiles. And this imagery goes on to receive greater expression in the so-called sun gate at Tiwanaku, which depicts a front-faced personage bearing staffs and has the rayed head, and then is flanked by these profile figures, these winged attendant figures, some of which have bird heads and others have human heads. These attendants, which are often flying, they occur in both Tiwanaku and Wari textiles. The example on the left of the screen is of a Wari winged figure, and it's still fairly close to the imagery of the sun gate. But a trajectory in Wari textiles is for these animals or these anthropomorphs to become more abstract. You see the wing here, which is compressed, and then the staff. But again, you've got the split eye. On the right of the screen is a Tiwanaku tunic, which was found with the burial of a child at Omo, near Moquegua. And you see the attendant figures here, again bearing staffs. But in this case, they have a llama head or a camelid head, and that's clear depiction of llama dentition. Rebecca Stone argues that it was important that Tiwanaku iconography was not only repetitive, but that its elements were recognizable in textiles and also in other media, along the far-reaching trade routes that Tiwanaku established throughout the South Central Andes. This tunic was found with burials in a cave at Pulacayo in Bolivia. And you have plain stripes of vicuña-coloured fleece and then patterned panels with the attendant figures. And although there's a lot of detail, the figure retains its coherence. Very striking, sonorous red and green-blue colour scheme. Again, you see the split eye and the staff. And here's a further example of a Tiwanaku tapestry, and shows the use of the green and the red and white highlighting. Also the split eye. Now, in contrast, different developments were occurring using the same formal visual elements. there are some remarkable Wari Camelid effigy figures that were found in deposits of smashed ceramic offerings at the site of Pacheco, which is in the Nazca region of southern coastal Peru. And some of these vessels have been reconstructed. They're large, they're about 75 centimeters high. This camelid here has the characteristic coloration of the vicuña, with the white underbelly and the white underneath here, but also white underneath the head. And these camelids are very realistically depicted. If you notice the eye here, it's not a human eye, which is often features in the ceramics. Another vessel from Pacheco has a black and white coloration, and this is a similar contemporary example of an alpaca with a white underbelly. So Wari spinners and weavers exploited the fleece colours that they had available in their tapestries. And in the hands of their weavers, the imagery that you see in the Tiwanaku tradition dissolves into an abstraction. You get glimpses of features, like these heads here. Also characteristic of this tunic is this diagonal arrangement of motifs. So you have a checkerboard outlined with white, then you've got another theme going along across these diagonals that skip over these plain carmine red coloured bands, which are plain. The tunic fragment here makes use of both black and white outlining. And the black outlining, I mentioned the outlining of the Nazca figurine, and you also have in Nazca textiles and tapestries, they are sometimes outlined in black. But in some cases, at least, it seems that the Nazca weavers dyed the fleece black, and rather than having availability of genuine black fleece from camelids. So this is another development that Wari weavers were able to establish. And you notice here that the dyed colour is complemented by the undyed colours, and to increase the range of hues. In addition to tapestry woven tunics, Wari weavers also made tie-dyed tunics. And to produce these scintillating textiles, it was necessary to have an all-white camelid warp and weft, woven in modular units, which would then resist dyed and reassembled. And the final result is an arrangement with dot and diamond shapes, and these lines that combine to make other forms. It's a kind of contrapuntal design of crosses and diamonds against the bold hues of the dyed fabric. Now, this is apparently a very wasteful use of what must have been highly prized white fleece, and it underscores the elite character of these textiles. It's not known whether these tie-dyed tunics were made in the Wari capital and the highlands, but it's likely that some of them were woven and dyed in the valleys that connect the highlands with the coast in the southern Peruvian departments of Ica and Arequipa, which is precisely the area in which the earlier Siwas textile tradition emerged. I'd also like to draw your attention to this stunning tunic, which doesn't come across terribly well in colour slides. But again, it makes use of white fleece, because instead of having the carmine red stripes, these stripes are this beautiful flamingo pink. And I suggest that this is not the result of inferior dyeing like the second batch of a dye substance, but it's intentional in the design. And I'd encourage you, once the pandemic is over, to hot-foot it to Santiago to see it, where you can see it in the Museo Chileno de Arte Pre-Columbian. And this is my final textile image of a panel in the Museum of Fine Arts, Boston, that demonstrates the use of wari pink against a carmine red ground. This combination of colors recalls some of the headbands known from the coastal site of Elena, as studied by Rommel Angelis and Denise Posey-Escott. The emphasis on the brilliance of white fleece appears to have been particularly attractive to wari weavers and also to the people who wore these garments, especially in the southern areas of wari influence. I finish by drawing your attention to the ceremonial site of Piquillacta in the Lucre Basin near Cusco. Gordon McEwen and Patrick Ryan Williams describe it as the abode of ancestors and the theatrical setting for rituals and feasts. They say its white plaster coating must have made it a shining beacon in the landscape. And once inside the complex, the visitor would have been led through narrow passages with high walls. And they say, quote, only the sky above and the path ahead were visible. This setting would have provided the context for the officials who populated the compounds, dressed in dazzling garments, the brilliance of which depended on camelid fiber for their effect. It's often thought that a lot of the increased availability of white in camelid fleece is a modern phenomenon, but I hope I show that there were developments in the past that give another light on the matter. Thank you very much.
Our next speaker will be Ann Peters.
I'm speaking today on Plants in the Tapestry, literally, a project developed with my silent partner who's here in the audience, Adriana Soldi. We share with you our ongoing research into two textile objects that form part of a Peruvian private collection. The collection was formed in the early 20th century by a family resident in the Ocucaje Basin in the lower Ica Valley, which is home to a famous wine hacienda where they worked developing the signature wines, the job that today we call enologist. In years of bad harvest or personal difficulty, local people often turned to excavating ancient ruins in the region and sold the objects they found. This family, like others in the region, became collectors fascinated with the pre-Columbian societies. In Peru, it is legal to have a private collection, but it must stay in the country. Our observations form part of the cataloging of their collection and the development of a publication that highlights some of the fascinating objects. The first piece we present today is a woven band. It's divided into rectangular segments, separated by a vertical line. In each is a feline figure with frontal face and profile body, spots on the body and bands on the legs, and feet represented with 3 or 4 straight toes. The head is narrow, with vertical ears, solid eyes, and a rectangular mouth with bared fangs. Below the head is an X motif, and above, a line parallels the margin of the head, neck, and back, forming a V motif that fills that space. When we began work, this band had been identified as Chincha, name of a famous regional power contemporary with the Inca Empire. Perhaps this was due to the X motif that resembles Inca symbols called tocapu, or the feline figure reminiscent of some Inca representations. However, we noticed that the spin, ply, and thickness of the yarns, the imagery, and the color scheme are all more characteristic of the Paracas culture that dominated this region more than 2,000 years earlier. We compared this figure with feline imagery on Paracas embroidered textiles and ceramics, including pieces from Ocucaje and others from the Paracas site to the north. There are many similarities in representational conventions, such as segments divided by vertical lines, the profile body and frontal head, the arched back and lifted tail, paired legs, sometimes with bands, 3 or 4 toes, and a line paralleling the back. However, there is no exact match. Comparing the piece with feline imagery on a late Paracas tradition triple cloth textile with an embroidered border points out a wide range of conventions that were used to depict feline imagery at the period, even on the same object. To our surprise, we noticed a much closer match in rock art, illustrated in a recent publication of the site of Illomas, far to the south on the route to the Arequipa region and northern Lake Titicaca. Objects and imagery similar to Paracas have long been reported from that region in the Siwa style. Might this band have come from the south? It is woven with cotton warp in an ochre hue, one of the colors naturally present in native Andean cotton. These are perennial small trees, unlike modern strains of industrial cotton. The colors of the weft yarns on the surface of the tapestry are dyed camelid hair. We have not yet identified the wild or domestic species. Wild vicuña hair was often used in the early textiles of this region, where they inhabit the high mountain plateaus. Domesticated alpacas have fine fleece and live in wetlands, like here at Lake Chocococha, where while llamas are historically used for transportation, but can also produce fine fleece. The warp ends of the tapestry band end abruptly and neatly, like those of a backstrap woven or staked loom. But camelid hair extension yarns loop through each end and have been loosely woven. A camelid hair cord passes through the outer loops in the same color used for the wefts. The other end is more complete, and here you can see how that cord forms a ring at the end, like the end of a hammock. This kind of end finish is a bit like knotted hammock-like head wraps found in tombs at Paracas and Ocucaje, but it is not exactly like them. The band is extremely fragile, and the center is damaged, though it might be nearly complete. But looking more closely at the weave, we see to our surprise that the white elements are not yarns at all. The white areas where most of the damage has occurred look surprisingly like basketry. Notice the difference between the fine, shiny, unspun weft elements and the camelid hair yarns next to them. These are tubular elements of a fixed length, and their ends stick out awkwardly here and there. Where they have broken, you can see the cotton warp yarns exposed, also damaged in those places. So what might this material be? A very fine tubular reed, rather like the kind used in this band, was used to make looped netted discs attached to a cane structure called a scoop or colador, typical of Paracas. Reeds are common in the coastal wetlands, dominated by bulrushes, a species related to those of California basketry. The genus, formerly known as Scirpus, is called totora in Spanish. These are bigger than the reed used on the band or on the scoops. However, there are other reed species present in the coastal wetlands of Peru, including fine reeds which are white when dried. Generally, reeds are first dried, then dampened to work with. But if they grow in salty water, they are more breakable and hard to work, so the local water quality is very important. Due to the shutdown of museums and research institutions, as yet we have been unable to work with botanists at Peru's National Museum of Natural History on reed identification. We also have further research plans to better understand the temporal and spatial origins of the materials used to make this band and what they might tell us about its makers. Now we fast forward about 1,000 years to consider this object, which has a tubular tapestry structure. You can see a series of images of profile or half faces and other motifs, rainbow-like arches, stepped diagonals, and hooked frets. Each type of motif repeats in segments within a band that continues all around the circumference of the tube. In Wari tapestry tunics, which define the middle horizon in textiles from Peru's central Andes, decorative bands are divided into segments, each with a diagonal line separating paired motifs, typically a profile or half face, and a stepped fret motif with a multicolor rainbow-like arch. Sometimes these alternate with pairs of camelid head. These bands are horizontal leftwise when they're woven, but they're vertical in the tunic as worn. The bands get narrower as they approach the side seams, as to give the illusion of a columnar form. I think we have good evidence that this tube is strongly related to those tunics. In the tube, the warps are not cotton, as in the wari tunics, but instead they are splints of wood. You can see this in places where a particular color of yarn is missing. The yarns move as in slit tapestry, occasionally interlinked with the adjacent color to hold everything together. The combination of camelid hair and cane splints occurs in other Middle Horizon artifacts. These small panels woven of canes and camelid hair with cotton binding yarns have been found hanging on the outer surface of Middle Horizon mummy bundles at Huacam Elena and other Central Coast sites. Taking a closer look at the two ends of the tube, you can see that it is a hollow cylinder, open at one end, with a cork-like cap inserted, while the other end is closed and rounded. Here are macro photographs of each, where you can see there's a cotton binding cord covered with a dark resinous material. The wide bound segment at the open end is edged by a decorative yellow camelid hair yarn. The narrow bound segment at the lower end is edged by a band of more finely spun and plied cotton yarns. A very similar tube in the collection of the Museo Chileno de Arte Pre-Colombino also has Middle Horizon imagery. It has a gourd cap with a biconical perforation, a cord that might have been attached to the cap, and the base is padded with an elaborate pattern of cotton binding. This tube contained cactus spines. Here you can see the open end of our tube with its cap. The tube looks dense, exactly circular in cross-section, with a quite smooth interior. The end is neatly cut, more so than the wood splints, which seem irregularly cut by hand with a sharp stone tool, and each differ slightly in width. The base is covered with a layer of resin. This gives it a rounded form. Covering the resin is a textile layer constructed by a spiral of close-worked simple looping, like the base of a looped bag. Perhaps it had been covered with diagonal pattern binding, like our comparative example. Looking more closely at the dense cork-like material of the cap, we see the hole has been drilled neatly through and realize that it may be modern. Remember that the owners lived and worked at a winery. They had brand new corks available. Perhaps they had seen that other tube. The margin of the opening looks so smooth and regular that we hypothesize that the material is a kind of bamboo or cane, either naturally open or with a pulpy interior that could be removed with relative ease, leaving the hard outer surface. Here you see a macro photograph of a fragment of looped camelid hair that has fallen from the base. The fiber, spin, and ply look quite different from the yarns used in the tapestry weave. The wood splints are from a fine straight-grained hardwood. This is often considered to be warango, Andean carob, that grows in the coastal desert. But there are other good possibilities, including canes, and their identification requires thin section comparisons. Caña brava, or arrow cane, is abundant on the south coast, where it grows in permanently running water such as major irrigation ditches. It was used for spears in the earlier Paracas times. It has open cylindrical segments blocked at the joints, but it isn't big enough or thick enough to make this artifact. Mountain bamboo grows in wetter zones, like the southern half of Chile or the upper eastern slopes of the Andes, mountain rainforest environments. These are the species with the right diameter for this artifact. Their interior, however, is full of vascular stem material, but the outer cane surface is the dense part. We need to work with the botanists on this identification. This tube is an exciting find, and there's more to determine about it. For instance, what is the resinous material? Is there a residue on the interior that could provide evidence for the use of this container? It might have also held cactus spines with powdered limestone to chew with coca leaves, or with hallucinogenic snuff like that identified on Middle Horizon wooden tablets found to the south. We hope you've enjoyed our presentation on plants in the tapestry and that you can add your questions to our own.
Our understanding of the choices weavers make in the use of specialized materials comes from the investigation of both the cultural significance of their source and their physical identification. In this paper, we will present the historical context for the use of special fibers from the Viscaccia, a rodent related to chinchilla, and the complex process of their identification. The Viscaccia is a small animal that has a long tail, tall ears, whiskers, and extremely soft body hair. It lives in the highland regions of the Andes. It is one of the exotic animal hairs, along with jaguar, puma, and wild guanaco, thought to have been used in Peru for special items, rarely included in the discussion of Andean fibers. Although it was mentioned in Anne's session today, I was grateful for that. I first began to focus on this small creature during my research for the 2004 exhibition, Colonial Andes Tapestries and Silverwork at the Metropolitan Museum. I studied the tapestries produced in the region with their hybrid designs and technical features that are key to the complex social and political interchange between the indigenous cultures of the Andes and the Spanish colonial world. One feature especially came to my attention during the installation of a beautiful late 16th century tapestry belonging to the MFA Boston. I noticed that amongst the Spanish style designs and European format at top and bottom were two little quirky light gray-blue animals, almost imperceptible and not seen anywhere else in the tapestry. And I started then to look at other tapestries, and I saw that off in a corner or subtly masked by a plethora of other visual motifs were a series of small, long-tailed animals depicted most often in a blue color. We see one nibbling Adam's calf in the 16th century tapestry of the birth of Eve from Adam's rib. They show up among the acanthus leaves in the border of a fine early tapestry with Neo-Inca designs, as well as scattered among the roses in a mantle for Santa Rosa de Lima. And in the corner and central rondelle of the 17th century Lado-style tapestry carpet. What are these animals and why do they show up like this in Spanish-style Andean tapestries? And why are they depicted most often in blue? We can identify the animal as Viscaccia, however, understanding the intentionality and significance of their blue presence is a bit more complicated. Viscaccia, or Viscaccia, is a Quechua word also used in Aymara, the two primary languages of the Inca Empire, and the animal itself is depicted in some Pre-Columbian textiles. The term is mentioned in early colonial documents, such as Cieza de Leon in his 1553 Chronicle of Peru, who notes that, quote, the wool of the animal was very soft as silk. Bernabe Cobo, in his 1653 History of the Inca, describes the color of Viscaccia as, quote, monkish and ashen. Garcilaso de la Vega, in his royal commentaries, notes, quote, in the time of the Inca kings and many years after, if someone has the opportunity to get some Viscaccia hair, they spin it to give variation to the colors of the fine cloth they weave. It is a thing very highly regarded by the Indios. They only use it in the clothing of the nobles. And we see here illustrated by Martin de Marua in his History of Peru, the wife of the second Inca holding a small Viscaccia in her arms, confirming this association with nobility. The animals live in some of the extreme environments where water is scarce, such as in the highland Salt Lake region of Bolivia. Cieza, in his chronicles, mentions that they are born in the rocky land and inside caves. And we see this today as well. Their characteristic fortitude for survival in this harsh terrain may contribute to the folkloric and almost mythic significance of the animal. Cobo in 1653 also attributes medicinal powers to the Viscaccia and notes that its hair is used in curing ceremonies for deafness as well as fever from kidneys. A ritual offering bag made of Viscaccia skin containing human hair inside was found in a hunter-gatherer cave in northern Patagonia, dated to around 1300 BC. And special bags made of Viscaccia and jaguar skins, along with ritual paraphernalia, including hallucinogenic snuff tablets, were found in a Tiwanaku-era context in Bolivia. Some years ago, while walking through the archaeological site of Tiwanaku in the highland region of the Lake Titicaca, I came across some soft, fuzzy hair caught in the dry scrub brush while talking with the very knowledgeable local archaeologist and botanist, Eduardo Pareja, who sadly just recently passed away. He thought that it could be Viscaccia and mentioned that local people, often women, make from the hair a yarn which is spun to the left and worn as an amulet around the wrist to protect health, well-being, love, and childbirth. Interestingly, Amy Oakland, in her important 1980s article about the meaning of left-spun yarn, mentions an archaeological find in Mojocoya, Bolivia, of a burial of a young girl who was wearing a left-spun twisted cord around her wrist. The use of the special Viscaccia hair in this way may imbue the item with even further significance. Left-spun yarn, called yoke, has a history and significance, especially from the highlands. It is used in certain garments, and as described by Wamapoma in his chapter on sorcery, even a single yoke yarn has agency and power. Knotted yarns, kipu, generally composed of cotton or camelid hair, have been used for record keeping since pre-Columbian times. Recently, one in the Quechua community of San Juan de Colata, Peru, is reported by Sabine Highland to contain some Viscaccia hair cords. The first I've ever heard of this. With the presence of Viscaccia hair in these highly significant contexts, I've been interested to try to find examples of Andean woven textiles, as very few have ever been identified. The first suspected textile came to my attention during the Colonial Project, and results of the study were presented here at TSA in 2006. The textile in question had been cataloged by the Cooper Hewitt Museum as Peruvian. We discovered that it had very interesting features, including yarns composed of spun down feathers, as well as animal fibers from what turned out to be rabbit and not Viscaccia as originally hypothesized. An unusual combination of materials for Andean textiles. After considerable study and analysis, I concluded that the textile must have come from Mexico and not Peru. But Viscaccia continued to be of interest, and I searched for examples while developing criteria to assess its potential presence. These fibers may be recognizable through their physical qualities, the softness of their extremely fine touch, as well as a kind of mottled color not generally associated with camelid hair. They also may, according to colonial references, be found mixed with camelid hair. However, as Viscaccia may be confused with rabbit, both visually and even under magnification, partnering with Caroline Solazzo, whose expertise in protein analysis enabled the accurate identification, in some cases, to the level of species ID. We began the current project in 2019 to test samples selected from archaeological textiles in various museum collections. To date, we've had only a few samples for our study. From the Textile Museum in Washington, D.C., a sample from an early Paracas knotted band that had one atypical yarn that seemed to signal something that caught my eye and appeared to have certain qualities related to our study. Petra Servinsky from the museum in Cologne provided us with samples of yarn from 2 textile fragments. The textiles collected in Pachacamac in 1914, are likely from the Ichima culture, approximately 1000 to 1500 AD. Petra had noticed an unusual physical aspect of the fiber used in one part of the textile. Scanning electron microscopy revealed interesting scale features. Sample 4 from the Cooper Hewitt Museum, we took fibers from a Nazca period narrow band that had one particularly special yarn that I had noticed when examining the piece many years ago and strongly suspected it could be Viscaccia. From the American Museum of Natural History, we were able to sample an Inca coca bag that had previously been suspected of being Viscaccia by Junius Bird. Our last sample comes from a fragment of a Highland warp pattern dress from the Fowler Museum, composed of an especially soft and mottled yarn. We have been able to sample, but it is yet to be analyzed. Now I will turn over the talk to my colleague to discuss the analysis and results.
So now we'll move to the proteomics identification of the textiles. And for that, I'm going to give you a little bit of a background on the methodology and technical aspects on how we do that. The basic element of animal fiber is a keratin protein, as you can see in the middle. 2 of them form a dimer. They bond together to form a dimer, and they further pack together to form intermediate filaments, as you can see in the top picture. And these intermediate filaments make up the bulk of the fiber. In addition to the keratins, there is a large family of proteins called keratin-associated proteins that forms a matrix that surrounds the keratin dimer. In the bottom, there is an example of keratin sequence where each letter represents an amino acid. And it is the amino acid composition and the order of these amino acids that makes a protein sequence specific to a species. So all species will have the same types of keratin, but with slight differences in their amino acid sequence, and that's how we can, they are distinct from each other. For the analysis, we start by extracting the proteins from a small amount of fiber, something like 1 milligram. The proteins are cut into smaller fragments called peptides with an enzyme. The mixture of peptides is analyzed by liquid chromatography mass spectrometry, and the result is a big pick list of all the peptide mass spectra. And then we import this pick list into a software that search the data against existing sequences in public database. Viscaccia is part of the Chinchillidae family, which is made of 3 genera. There is the Chinchilla genus, the Lachidium genus, and the Lagostomos genus. Chinchilla and Lachidium are native to the Andes Mountains that include parts of Bolivia, Peru, Argentina, and Chile. The 2 main Lachidium species are the northern Viscaccia, Lachidium peruanum, and the southern Viscaccia, Lachidium viscaccia. Then we have the plant Viscaccia, Lagostomos maximus, that is the only living species within the genus Lagostomos, and it is found in Argentina, Bolivia, and Paraguay. The existing protein databases are limited because not all species have had their genome sequenced yet. Usually the species that have been sequenced have a commercial value, which is the case for the chinchilla. But in the case of the Viscaccia, no keratin sequences are available in public database. Luckily for us, chinchilla is a close relative of Viscaccia. So if we have Viscaccia in our samples, the best match that we can expect from searching public databases is the chinchilla. So here are the results we obtained from the different textiles that Elena described, and by doing a general search against public database. So the Cooper Hewitt sample that had been identified by microscopy as rabbit indeed came back with a perfect match to Oryctolagus cuniculus, which is a Latin name for domestic rabbit. So what you see in this table are the top protein matches, which are the different chains of keratins. Then you have the protein identification score, the percentage coverage, which corresponds to how much of the protein sequence is identified, and finally, the number of peptides identified. So with the best match at 73% of protein coverage, we can confidently say that the sample is from a rabbit species from the Lepidorae family, since the public database only has domestic rabbit sequenced. Next sample is the Textile Museum sample, and this one came back with a mix of camel and alpaca matches, which allow us to say that we have an identification to a Camelidae species. And this is because, again, the South American camelids have not been completely sequenced yet, so we have more sequences for camels and compared to South American camelids that are really incompletely sequenced. So we only have a few sequences from alpaca to date. However, I didn't go further in the identification as this was not the purpose of this study. Now we turn to the samples from Cologne, and things become more interesting because here we get the expected chinchilla match, as you can see in both samples. So the top matches are for chinchilla laniera. We also get very nice coverage with over 70% protein coverage, which is a reflection of how good the preservation of the fiber is. We have some matches to Cavia porcellus, which is a domestic guinea pig. So again, that shows that probably we don't have quite the exact match with chinchilla, but definitely a species from the Chinchillidae family. And for the Cooperi wheatband, we have the same results. So we have a match to chinchilla, best match to chinchilla. So out of 5 samples tested, 3 were potential Viscaccia, which was very encouraging. But of course, I wanted to be as thorough as possible, so a chinchilla match is not quite enough. And we want to know if proteomics can tell the different species apart. So for that, I tested 3 specimens for northern, southern, and plain Viscaccia to create my own database of markers for these species. Specimens were obtained from natural history collections at the American and National Museums of Natural History. To create my database of specific markers, I needed to identify new peptide sequences. And the way we do that is by looking at amino acid substitutions in known sequences. We use a technique called de novo sequencing or manual sequencing to match spectra to new peptide sequences. So here you have an example of mass spectrum. The mass difference between each peak represents an amino acid. So if we have a good spectrum, we can build the sequence by adding the amino acids corresponding to the mass difference between each peak. And the next one is in green here is an example of a new peptide that was sequenced for the Lachidium species, with on the right is mass spectrum. So the difference with chinchilla that you have in red, the sequence in red, is that for the Lachidium, you have a K, which represents a lysine, which stands for lysine, instead of a T for threonine. And this sequence in green was found specific to Lachidium. While the next sequence in blue, if you click next, here you have a peptide that is specific to Lacostomos. And again, I've highlighted the amino acids, amino acid substitutions. So next, so the process is repeated many times. And here is a summary of the sequences that were found with, in green, the Lachidium species, in blue, the Lacostomos species, and in red, the chinchilla. The first peptide, which was the one from the previous slide, is a robust marker for Lachidium because it was found in all 3 textiles. There was one more specific Lachidium peptide found in 2 textiles in the second to last lane. But you can see that none of the chinchilla or Lacostomos specific peptides were found. In addition, there were 6 peptides that were common to chinchilla and Lachidium, and 1 peptide that was common to Lagidium and Lacostomos. And some of them were identified in the textiles as well, which are marked by a green X's. In fact, these results seem to indicate that the Lachidium species were more similar to chinchillas than they were to Lacostomos. But overall, the conclusion of this work is that all three genera can be differentiated and that the textile samples were matched to Lachidium, so either northern or southern Viscaccia. And finally, the results on the bag are presented here. So out of the 7 samples tested, 1 sample was identified as a Camelid, only 1. 6 were matched to Lachidium, with at least 5 having 1 specific peptide. And finally, the last sample didn't yield any proteins, so it was likely a plant fiber. And indeed, when we looked at the sample under the microscope, the fiber was identified as cotton. Sorry.
Thank you. Now we move on to Andrew Hamilton.
So good evening. I just wanted to start by thanking Elena for organizing this great panel. It's really a pleasure to be able to present this research. As some of you may know, I'm writing a book called The Emperor's New Clothes, the Biography of a Royal Inca Tunic. It focuses on an Inca unku, or a man's shirt, conserved at the Dumbarton Oaks in Washington, D.C. It's arguably the most famous work of Andean art in any media, the Mona Lisa of the field. Part of what has garnered it such attention is it's the only known surviving Inca tunic that's entirely covered in these small rectangular motifs called tacapus. The trait suggests that it's exceedingly important. We can recognize this style of tunic in the illustrations of 3 different manuscripts created around 1600. Felipe Wamapoma de Ayala's well-known chronicle, and 2 versions of Martin de Marua's manuscript, often referred to as the Getty and Galvin Maruas. Combined, they depict this style of garment 13 times, and only ever on the body of Inca rulers. The many artists behind these images adamantly express that this is a royal Inca garment, and in fact, the only known surviving royal Inca object in the world. Recognizing that we celebrated Indigenous Peoples Day earlier this week, this makes the garment a powerful testament to Indigenous sovereignty in the Americas, along with Powhatan's mantle and Montezuma's headdress. Now, because of how prestigious it was, the tunic was woven with some of the most luxurious fibers available throughout the Inca Empire. While its warps are cotton from the coast, its wefts are extremely fine camelid fiber from the Andean highlands that have been dyed myriad colors. It's probable that they're the softest neck and belly fur of the white domesticated baby alpacas, but it's also possible that they came from the white undersides of the far rarer and finer wild vicuñas, which we've already spoken about. Now, unfortunately, because of the structural similarity of these 2 fibers, it's difficult to distinguish them morphologically. One of the major conclusions of my book is that this masterpiece of Inca weaving is actually unfinished. In making it, the final touch would have been to embroider a zigzag line across the bottom selvage. We can see that example of that detail here on the bottom of another Inca tunic. Someone started embroidering that line, but stopped halfway across one side of the vestment. There are 62 needle holes arrayed in a zigzag. The textile is so extraordinarily fine that the very act of sewing it severed the minute wefts. From the colonial accounts that discuss how Inca emperors wore garments, it's unthinkable that an emperor would don this illustrious tunic in an unfinished state. And because it would have been created in a government-sponsored weaving compound, it seems equally unlikely that such an important textile which would have taken untold months to produce, would have somehow fallen along the wayside when it was maybe only an hour from being completed. The most plausible way to explain the emperor's new clothes is that by the time the garment was near completion, it was the emperor himself who had disappeared. That is, I think that the tunic was being woven at the time of the Spanish arrival, most likely for Atahualpa or Huáscar, half-brothers who were at that point engaged in a bitter war of succession. After Huáscar was murdered by the Atahualpa soldiers and Atahualpa was executed by the Spanish, there was no clear heir to the throne. At that point, it seems possible that the tunic came to be worn by someone else in the royal family, or a nobleman who had access to the royal lines of production. It's clear that the tunic was worn and torn at some point. Someone attempted to repair the heirloom garment so it could be worn again, but they lacked the skills of the original makers. Sometime thereafter, it was torn another time and not repaired until the 1940s, seemingly, when it was prepared for exhibition at the National Gallery in Washington, D.C., as part of the collection of Robert Woods Bliss. My work on the Dumbarton Oaks tunic excavates the hidden stories of a phenomenal textile and the lives of the humans who wove and wore it. Even so, what's challenging about this object is that we can really only understand it in isolation. It is the only surviving Inca tunic that can be shown to have likely been of royal caliber, because all the material things that touched the emperor's semi-divine bodies, whether their sumptuous clothing or the scraps of their food, were gathered together annually and burned. All objects still in their possession at the end of their lives were similarly burned in a funerary rite called the Purukaya. Added to this, remember the huge quantities of objects destroyed during the Spanish conquest. Let this sink in. In our studies of Inca art, I do not think scholarship has really wrapped its head around the fact that we're missing all of the very highest echelon of their artistic achievements. Our whole understanding of their artistic style may largely be born out of second-tier works. While there's the possibility that other royal tunics exist that also somehow escape destruction, they're apparently not stylistically distinct enough to be identifiable. If colonial manuscripts are any indication, it would seem that much of the time emperors just wore finer versions of the same generic styles that other noblemen wore, like this simple black tunic. To identify a garment like this as royal, we could only speculate based on the caliber of fiber, spinning, and weaving. But because the Dumbarton Oaks tunic has the highest thread count of any known Inca textile, with around 100 wefts per centimeter, it's difficult to guess where that threshold or cutoff might have been. Thus, I'm left to wonder about the regalness of an Inca tunic in the Berlin Ethnologisches Museum. It has a very fine hand and high thread count. Notably, it's child-sized, which seems to indicate that its wearer was born into a high social station. Even more remarkably, its neck and armholes were carefully cut open and bound with embroidery to enlarge them, as if to extend the life of the garment for the body of a growing boy. I also wonder about the hidden story or human life behind an extremely fine and also very well-known Inca tunic in the Museo de America, Madrid. Its floral motifs are unusual for an Inca textile. The presence of silver-wrapped thread along its edge confirms that it was actually woven in the colonial period and potentially embraced the European fashion for floral cloth. While it certainly was a very elite garment, whether it was royal per se is difficult to judge when the Inca monarchy itself had at this point been so deeply compromised. In the colonial period, Inca sumptuary laws fell away, allowing more indigenous wearers to commission ennobled garments. As a result, there may actually be more surviving Tekapo tunics from the colonial period than from the height of the Inca Empire. And so, without other examples of royal Inca garments, it becomes very hard to art historically consider the Dumbarton Oaks tunic in any kind of context. But history offers a hidden story of another one of Atahualpa's remarkable garments. While the Dumbarton Oaks tunic perhaps never reached the emperor before his death, the Chronicle of Pedro Pizarro tells of an extraordinary ensemble he was wearing in the weeks or months before. Pizarro was a 17-year-old at the time of the conquest, and the page of his more famous relative, Francisco Pizarro. As a result, he was not only an eyewitness to the conquest, but as someone who traveled within the innermost circles of the Spanish ranks, he also had intimate access to its main protagonists. In one of his chronicle's most memorable sections, he wrote about his first-hand interactions with Atahualpa while he was imprisoned in Cajamarca before his execution. Pizarro started by describing Atahualpa's appearance, saying he was a fine person, of medium size, not too fat, beautiful of face and grave with red eyes. He went on to explain that Atahualpa always wore extremely fine clothes. To substantiate this, Pizarro recounted a particular incident that took place inside his cell. Atahualpa's female attendants were serving him dinner upon gold and silver and ceramic vessels, atop a layer of green reeds, which seems to have functioned something like a tablecloth. As the emperor ate, however, a drop of food fell onto the tunic that he was wearing. He immediately rose and disappeared into the other room to change his clothes. When he reemerged, he was wearing a gray-brown tunic and a matching mantle. While this sounds somewhat drab, something about it must have caught Pizarro's eye, enough that he was moved to touch it. And the emperor, evaluating in terms of European fibers, he claimed it was smoother than silk. He asked Atahualpa what it was made of, and the emperor replied, "It's made of the birds who fly by night in Puerto Viejo and Tumbes, and who bite the Indians." Somewhat incredulously, Pizarro retorted, "How is it and where could so much bat skin be gathered?" And the emperor replied, like a true fashionista imperialist, "Those dogs of Tumbes and Puerto Viejo, what else did they have to do with capturing those animals so as to make clothes for my father?" This passage had a huge impact on subsequent Spanish authors. Although Pedro Pizarro is the only chronicler I know of who claimed to have personally seen bat fur garments, this knowledge resurfaced in numerous later texts written by other colonial authors. That said, I'm unaware of any modern scholars having ever found an Inca textile made of bat fur, although a simple explanation is that they were burned alongside the countless other garments in the emperor's wardrobe. Still, the seeming implausibility of this feat may understandably lead some to wonder if Pizarro's account was apocryphal. Indeed, although Pizarro saw the wonders of the Inca Empire at the time of the conquest with his own eyes, it took him nearly 40 years to put his account to paper, and he only finished his tome in February of 1571. The long delay raises the question of what he might have misremembered or embellished for the sake of good storytelling. Even so, the passage strikes me as unusual for a Spanish chronicle, as it's one of the few episodes where a colonial author not only described a unique article of clothing that he directly observed an Inca emperor wearing, but also where the discussion of the garment was the express purpose of the passage. What's also unusual is that he did not claim the ensemble was beautiful or visually spectacular. In fact, he did not render any aesthetic judgment about the gray-brown garments at all. Really, it may not have looked so different from the simple monochrome tunic and mantle that his father, Huayna Capac, was shown wearing in the Getty Marua. Now, since I first read this passage and pondered it, these traits led me to think that the garment may actually have existed. But how? I set out to research this and stumbled into the office of Judy Chapasco, former curatorial associate in the Department of Mammalogy at the Harvard Museum of Comparative Zoology. What started with Judy one day showing me Harvard's enormous collection of bat specimens eventually ended with her teaching me to skin a bat myself. Understandably, this research is hugely indebted to her. Now, first and foremost, Pizarro was not wrong in the basic premise of his description. There are 3 species of vampire bats in South America, and one of them, Desmodus rotundus, the common vampire bat, does in fact inhabit the far north coast of Peru in the area of Tumbes and Puerto Viejo, while the other 2 hail from the other side of the Andes Mountains in the Amazon rainforest. But while vampire bats may have been the most conspicuous species of bat because of their propensity to bite people and livestock, it's worth questioning whether Atahualpa would truly have been naming a specific species in a Linnaean way, or merely referencing a whole order of animals by their most well-known and easily identified member. Indeed, there's a huge diversity of bats in Peru that can be very difficult to differentiate, with at least 114 species currently identified. Notably, even 250 years after Atahualpa's death, in the 1780s, when the Spanish bishop Balthazar Jaime Martínez Compañón created his sprawling 9-volume natural history in the north coast of Peru, comprised of 1,411 watercolors, he only included one generic illustration of a bat, simply entitled Murciélago. Critically, it's an image that reinforces Atahualpa's understanding of these creatures, because the illustration was not included in the Mammals Volume 6, but rather was categorized with the birds in Volume 7. Indeed, it was placed at the very end of the volume, followed only by an illustration of a deformed 4-legged baby chicken titled Pollo Monstruoso. Thus, in this region, even according to much later Enlightenment thought, bats were seemingly regarded as a sort of misshapen bird. Now, it might seem like bat fur would be so short that it could not be spun. This could lead you to think that perhaps the fur was transformed into a garment by sewing the skins together. But there are 2 issues here. First, as I learned from skinning this bat, Their skin is as thin as tissue paper. The leather has very little integrity. Not only would it shred, but also its hand would in no way be similar or superior to woven silk. Second, as we can see in the Inca's attention to rainforest communities, a province of their empire called Antisuyu, they looked down upon those who wore raw animal skins as uncivilized. Indeed, we can even, if we examine Wamampoma's illustrations of the phases of Andean civilization, in the first epoch, people wore leaves. In the second, they covered themselves with animal skins. But in the third, they discovered spinning. And only after that did Andean culture enter the age of the Incas, where they finally wore woven regalia. This aversion to wearing animal skins emphasizes the ideological importance of woven cloth for the Incas, and makes it seem unlikely that their emperor would have worn garments constructed from whole bat skins. Another issue we might wonder about is the size of bats. Perhaps to get the longest and most spinnable fur, the Incas would have wanted to harvest it from the largest bodied bats. But in reality, the largest bats in this region are fishing bats, and their fur is barely longer than velvet or flocked paper. Smaller bodied bats, such as the common vampire bat, actually have much longer fur. We might think of bats as having a bullet-shaped body, but as this photograph of a hairless baby bat suggests, they actually have a well-defined neck. It's just covered in a mane of fur that can reach 5 to 7 millimeters in length. In at least one species of bat found in Peru, the hoary bat, the fur of their mane can be as much as 1 centimeter long. Now, 7 millimeters might seem like an impossibly short fiber to spin, but this really raises a question of scale and aspect ratio. Consider that the staple length of cotton might be 2.5 centimeters long, or 25 millimeters, while its average diameter is around 26 micrometers. Bat fur may only be 7 millimeters long, but its average diameter is a mere 8 micrometers. Thus, the ratio of length to diameter for both fibers is more or less the same. While bat fur would obviously be much more delicate work to spin, its fineness would conceivably allow it to take up enough twist to lock the fibers in place, creating a thread with tensile strength. But bat fur has one more hidden property that would have proven advantageous in spinning. And I thank T. Rose Holdcraft at the Harvard Peabody for helping me see this, who I think might actually be in the audience. If you look at it under a microscope, it has a very strange morphology. The scales of its cuticles are described as coronal. They stick out from the shaft like spires, spines, or the thorns of the stem of a rose. This gives them a Velcro-like property. They glom onto each other, which would have seemingly helped in drawing the fiber. Although I have only experimented with spinning bat fur in an extremely limited way for lack of sufficient quantity of fur, even in my very mediocre abilities and on my first attempt, I did not find it impossible. This is a photo taken through a microscope of a segment of spun and plied bat fur thread. It's of course minuscule, but it's not inconceivable that the fiber might have been used as a weft, possibly with a stronger camelid fiber as the warp. So in discussing these results with Judy Chapasco, I too found myself asking the same question Pizarro did. How on earth do you get your hands on enough bats to create a whole tunic? Judy shrugged. Given her experience collecting specimens for the museum, she explained that all you would have to do is spread a mist net across the mouth of a cave at dusk, and you could catch as many as 50 or 100,000 bats in an evening. I have my doubts that Inca Bat Hunters had some sort of catch and release program, and I can only imagine that their transformation into the emperor's new clothes would have been fatal. My guess is that the animals would have been skinned and perhaps shaved with an obsidian blade. While I still cannot prove that Atahualpa's storied tunic and mantle were created in this way, I hope I have sufficiently persuaded you that it's least within the realm of possibility. And should you look back on the Dumbarton's tunic now or in the future, I hope that this helps you see it through a slightly wider lens, that it was not some artistic outlier, an isolated achievement, but rather one of the many wonders that Inca weavers created at the behest of their emperor. Thank you.
I will ask all our speakers to please show their faces. And I invite questions from the audience, which is quite large. So if you could please use the chat, Loretta Crippen says that while doing a alpaca project, I read in numerous references that the vicuña fiber used to be different in pre-colonial times in terms of fiber. It will be interesting to see if micron size varies with later vicuña, if at all possible. I think I would field that to Penny. Do you have any comment about, you mentioned a change in the in fibers. Do you have a thought about that?
Thanks for that question, and it's important to question received wisdom. And the research that I know of has been on llamas and alpacas and how they've changed from pre-Hispanic to contemporary times, and it is often assumed that the wild forms of vicuña and guanaco have not really changed. But of course, we know that especially during the Inca period, that there was, and Andrew mentioned the hunts and the shearing and release of animals, and if there is a tendency, if an animal is sheared, then the regrowth is a bit coarser than the original fiber. So it is something that is actually very difficult to test, because I don't know of any securely identified mummified remains of vicuña that retain the fleece to do the research. I hope that answers the question.
That reminds me of an interesting comment I read by an archaeologist from Chile that was talking about these early finds of Viscaccia, and mentioned that apparently when a Viscaccia is killed, it releases its hair, that somehow it sheds its hair after death. So I don't know if that's relevant for any of these issues, but it's kind of, it makes this idea of plucking hairs, or perhaps also from the bats, that if there's any kind of process that takes place naturally to for them to shed their hairs.
That's an interesting comment, that there was no indication of the time scale, because what herders do when they, especially if you want to use llama fleece, it would be to sacrifice the llama and then to leave the hide in the sun for a couple of days, and then it's easy to pull out the fleece, and you wouldn't need to shear it. So that should be detectable.
Plucked hair.
You can see the root of the fiber, whereas if it was shorn, sheared, you'd see it was cut at the ends.
Actually, now that I'm saying this, in fact, it was talking about a fright response as well, at least in the case of the Viscaccia, that if it's frightened, like a porcupine, it releases its, it has a releasing mechanism somehow, but its hair. And so the predator who's biting it will get a mouthful of hair and not the animal itself.
My understanding from taxidermists is also that as the specimen rots a bit, that I think it's called slipping, that the fur or the feathers of the animal will start to slip out, because essentially the connective tissue that connects the fiber is one of the first things to get eaten by bacteria. So yeah, I mean, it is possible that if you let all the animals rot, you might just be able to sort of pull it out. But I'm not sure to what degree that might damage or cause the hair itself to decompose in a way that would be not pleasant to wear.
Andrew, there are a couple of questions for you that have to do with, did you find any ethnohistoric information about mythical or ritual properties of bats that would have made the garment with their hair particularly desirable?
There's certain creatures that are considered negative for the Incas. One of their forms of punishment was actually to put someone in a chamber filled with wild animals. And if you could survive sort of being terrorized by these wild animals for whatever period of time, then you were absolved of your sin. Poma depicts this. I'd have to go back and check and see if bats are actually sort of in there. It seems to be like a lot of snakes and lagartos and things like that. Cats. But it would be interesting to see if that's somehow affiliated. I mean, I think that it's really just, I mean, this is, I mean, you know, if cashmere is 18 to 14 micrometers in diameter, I mean, this is like 8 to 10. So I imagine a lot of this really just is like the absolute fineness of the fiber that drew people to it.
And I see you mentioned that to Anne that there's another thread wrap case in the Art History of Art Institute. And I would also say there's one in the Fowler Museum, which in the case, which is very similar, and it has a closing, it has needles. It has sewing needles. It's not as elaborately patterned as yours, but it is designed with colored. It's more geometric patterning, but so I think there are a number of those cases. It's a very interesting thing because we don't find them in the context of the weavers' sewing kits, right? We don't see them in the baskets with the threads. I don't know if Romulo, who I believe found such a beautiful set of prepared materials, I don't know if he found any.
I've talked with him about it. Yeah, there is one in the Amino Museum that seems to be the outer panel before it has been applied to the tube. So I'm really appreciating these other examples. Knowing about the one in the Art Institute and at the Fowler is great. That's because I think that we really want to look at the genre. And if you see any more of those bands with with the white, we would like to look at that genre too. Yeah. So we have a genre of one on that one. Yeah.
Someone was asking about the left spun yarn, and the article I cite is Amy Oakland. Also, Anne Rowe has written about it. I've written about it in other contexts, as has Penny. So there's a number of articles that deal with this issue of left spun yarn and the significance and the context that it's found in. Andrew, can you speak about the role of embodied knowledge, firsthand skinning and spinning, has in the larger picture of your research? And how do you see it proceeding going forward?
That's a great question. I actually wrote an article that came out earlier this year. I think it probably is on JSTOR by now, called New Horizons in Andean Art History. It came out in the Princeton Record. And sort of the way it talks about this, these kinds of approaches. And essentially what I'd say is I think we often treat Andean archaeological material culture as examples of types. Because of looting and because of sort of the lack of written records about the objects, we think that, you know, we can't really reconstruct knowledge about them. We don't have any testaments to them. We don't have their context. We don't have discussions of them. Part of what I think in my approach this way to studying these works is that there's the firsthand testament of the maker. You know, there's all the knowledge that they had, and they obviously make series of choices as they're making an object. And if you can reconstruct what they knew, what they did, and why they did it, it gives you another perspective on the object that might be less obvious if you don't actually know how the objects were made. So I do try as much as possible to at least have a go at trying to figure out how the different objects I study were made. And it's something about making is that when something goes right, it looks like it's effortless. And so figuring out what the hard parts of making an object actually are, a well-achieved object, it often elides what the real difficulties and skill sets were of the maker, because they've mastered them so well. And so I think it's often in figuring out what sort of the hand positions are, the techniques, the way your body has to sort of be engaged in the making of the object, how you're prone to backache or shoulder ache or whatever, actually can sort of then give you insights as to how it was made, and even explain some of those kinds of errors and things. So yeah, it's but I invite you to see the article, and I can send a PDF if you don't have access to it. But yeah, so I find it helpful for me for thinking about objects and wrapping my head around them. Thanks for the question.
There's a question for Penny. You mentioned fleece being dyed black in a wari textile. What plant and or mineral material was used to make black dye?
It was actually in a Nazca textile. And you sometimes see Nazca tapestries that have a rather lovely clear red background, slightly orangish, that's not like the kind of carmine color that you get with the wari textiles. And then the actual motifs themselves have a black outline, which might be just done over a couple of warps. And that black might be eaten away. So these are textiles I've observed in museum collections, but I presume it's the mordant that would have been used in the dyeing that makes me suspect that it wasn't just black fleece, and that the wari spinners and weavers did have access to that black fleece in a way, in a standard, in reliable quantities, that they could produce textiles of a certain type and then repeat them. So there's a shortage of dye analysis, and there's exciting work that's starting now. And of course, Elena, you've been one of the people who've been involved in projects like that.
But I think if you're describing that the black is, so often we see in Andean textiles the black color in perfect condition, or in the condition in very, very well preserved. And in the cases when it is not, and it really is deteriorating, we make the assumption that there's probably some kind of iron mordant or iron in the water that's causing the protein materials to disintegrate. And we see that all over the world. It's not confined to the Americas. It's a universal issue about black dyes and with iron that tends to deteriorate the fiber.
Yeah, thanks, Elena. That puts it better than I was. There is another point that black fleece, black fibers are often finer than the other other camelid colors of fiber. So that's another point of information to take into account.
It's interesting you say that, because there are some black garments, and in the highlands there's a whole long history of wearing black garments, at least from the colonial period on up, and some of that black fiber is so shiny and so finely spun, and it's astonishing to see the quality of that black. And I think, we think of as black garments that might be sort of just like, as Andrew was pointing out, you think it's this plain black thing, but in fact that black is luminescent. And then on top of it, some of them have this S&Z spun yarns, which make for a whole other resonance through you know, light hitting it, and the black yarn becomes like a mirror. It's so shiny. So
protein fibers are particularly good for reflecting light, but also for dyeing. And I think that's what makes them, in terms of our panel, that makes them particularly extraordinary. Is that you can get the fineness, but also you get these light reflecting qualities.
Yeah. I have a question for Caroline, if I may. I think all of us in the Andean textile world would love to be able to differentiate between alpaca and vicuña and llama. I mean, sometimes we can do it visually, sometimes we can do it by touch, but to have that security when it, you know, the part of the problem is the inbreeding of the animals, and that they're not they're within the same family. So do you think there's hope to find a way to work with analytical methods to be able to securely identify?
Yeah, I think there are some, well, I know of several groups working on this, and hopefully in the future there will be some techniques, not just by proteomics, but other maybe other techniques. From my experience, yeah, it was very difficult to do it by proteomics because they were really identical, but the techniques is evolving a lot and it's always getting better. So I think maybe in the future it can be done maybe soon.
Are there any particular labs or places where people are, you know, immersed, you know, really working on the subject that you know? Or I know there were some people in Canada. I don't know where they were from, but
I don't know about Canada, but I know Museum of Natural History in Paris, so we're working on it. I'm not sure where.
Yeah.
But, they had I think they had a postdoc to do this.
Right.
Yeah, we have to keep thinking, but might be there soon.
Good. We need it. We need it. Someone had a question about human hair and the use of human hair in Indian textiles. Maybe I throw that to Anne. Is that something you can answer? The presence of human hair in Indian textiles?
Oh, yeah, human hair is extremely important in Paracas, and it's used particularly for headdress elements. It's used symbolically as human hair. It's not used as a component that would disguise its human hairness. But also there's camelid hair that is selected for coarseness and is used because it resembles human hair, to imitate human hair. So that's not human hair looking like something else, something else looking like human hair. I mean, just within the Paracas world, we have those things.
I just mentioned that in the Atacama Desert, you get the use of human hair as well. And it's not terribly common, and it's sometimes used for repairing textiles. But there is a very, from the South Central Andes, from the Chiribaya area, so, you know, far south of Peru, that there's a nice little band in the Maimon Museum in Israel that has been identified as having human hair.
There's a really extraordinary wig in Yurtoboy, in the museum there, that's all made from human hair, as sort of as Anne was describing, as a headpiece. And then as Penny was saying, the Dumbarton Tunic actually has a lot of human hair in it, but it's repairs, and those are actually, and speaking with Anne Rowe about it, those are probably the repairs that date to the mid 20th century, as the textile was prepared for exhibition at the National Gallery. I gather that was a pretty common textile conservation technique, because of the length and strength, but then also the slipperiness of human hair. You could carry it through the channels of the wefts to shore up the broken warps underneath. So there's sort of like little zigzags of human hair all throughout it, that especially blonde and white hair that sort of appear slightly translucent and then aren't so visible as you look at it.
The American Museum of Natural History definitely used it in the restoration of their Paracas mantles. In a period before that, very fine silk threads were available that many conservators use now. Someone asked the very important question, did I miss the answer? Was there an explanation of why the Viscaccia was blue? And it's true, I didn't really answer it because, but what I was trying to build an argument for, and I guess we have to go back to this strange absence of the use of blue dye in Inca period. And in Inca tunics, we find it only in a few very important tunics, but it's used frequently by the Wari. It's used in up and down the coast. It's used for a lot of different cultures, but somehow in the Inca times, there's very little blue used. Now, most of the indigo blue would come from the selva, from the eastern slope of the Andes, whether it's a political thing, whether it's a local thing. I don't have an answer to that, but when I started to see in these colonial tapestries that this animal was always blue, to me it was a signal of something important, and that this animal, which has these different kind of associations with curing and with medicine and with some kind of amulets for health and well-being, I think that I think it means something. I don't have the answer exactly what it means, but to me it represents something that's very different, and it's something that doesn't show up in you know, where we see it in these colonial tapestries. It's very obvious that that's often the only thing that is blue is the Viscaccia that's represented. I don't know, Andrew, do you have any thoughts about blue and the Inca?
Well, it's something that I've been actually studying with the Dumbarton Oaks tunic. There's some sort of, one of the reasons I think that we see a lot less blue dye in Inca period textiles, but also throughout the period, is that there's some kind of dye fading going on. So there's a blue that does remain in the Dumbarton Oaks tunic that's a quite dark indigo. And then there's another color that is often confused with it by the weavers, but now that color is sort of a tannish color. And the
so
tannish,
I would dye of some
yeah.
sort.
So it appears to be, you know, solving for the variable of what it is. It's used as if it were blue to the weaver's eyes. But since understanding that in the Dumbarton Oaks tunic, I find it sort of widely in textiles from a lot of different periods. I know Anne Rowe is working on some really exciting analysis of dye fading as well, and I wonder if, you know, if the same dye stuff is the culprit, or what dyes, you know, what range of colors this potentially fading dye could have been used to produce, and you know, if it ranges from green to blue or what. So
I think you should also consider over dyes, because the relationship, so that also affect the changes over time.
Yes, but indigo, there's a long tradition of using indigo, and those that know how to use it, and it's not an easy dye to use, and it does not come, you know, it needs that semi-tropical side. So it's
there was a lot of it in the Ica region in the early days, and then it disappeared. It was basically destroyed by agricultural expansion. Yeah, the botanists have traced that. So I thought that may really account for the fact that you have a huge amount of really well-fixed dark blue. In Paracas, it doesn't fade.
Mm-hmm.
And I mean, how dark it is depends what it's over dyed on.
Mm-hmm.
But then that color becomes extremely unusual, and more of the later blues, the sort of medium blues, one of the things to take into account is that they're generally dyed on gray camelid. So, but the medium blues,
Mm-hmm.
so what's underneath it is either sort of a gray to
Mm-hmm.
a cream white camelid. They're selecting the fiber.
But then we have these so-called Inca key tunics, which have this dark, dark, dark purple, which is usually really dark, or purple black, and that's actually a really, really dark blue with probably some other aspect to it. But anyways, so blue is an interesting color, and it's a kind of it brings up issues, and to me it signals something that is going on in association with this animal, which has this ability to live in these areas where there's almost no water. They live in the rocks, they live out, in the sunny area. They also have, their habitat is also in somewhere more grassy areas, but the fact that they have this survival, I think is a quality that gives them an added thing. And so showing them in blue is also another signal that there's something special about this animal.
Can I add that Rebecca Stone says that blue and blue-green in Wari textiles, she calls them, they're often like a wild card. That's in the regular patterning sequences that the weavers would do something unexpected, and it'd be often in the blue or the blue-green color.
Yeah.
And because there is the association, in Tiwanaku with the greeny blue and water, which might be interesting in the context of Viscaccia.
Yeah. Well, I don't know if you have any other questions. It's we've had a long day, and I think it's been a really wonderful panel. I want to thank the panelists for their incredibly interesting work and their long-term commitment to this field. I'd also like to thank our 107 participants who stuck it out. And I appreciate everyone's thoughts and interests, and there's ways to contact all of us through the TSA app if you want to do so, and I'm sure that we'll all be open to sending references or being in touch. So I think I will close the meeting now. Thank you very much, and have a good night.